So your H naught is always going to be equal. This is what tells what kind of test it is. Is this a left tail, right tail, or a two-tail?
Left tail.
This is going to be a left tail because it's pointing to the left. Now, it says what parameter is being tested. They just want you to know that the P is being tested. The P is what we're looking at. It's that easy, y'all. The P is what, the parameter is what's being tested. And because it's less than, that's why it's a left tail test. We good? Sure we are. Let's go again. What kind of test?
Right.
Right tail test, what is being tested? The parameter, the P. It is a right tail because of that. And the parameter, proportion, population proportion, that's being tested. The P's being tested. Yay? What kind of test is that? The two-tail test. And what's being tested? Sigma. Which is your standard deviation, your sigma. So this is what's being tested. And because it's not equal, that's why it's a two-tail test. Say that 3 times fast.
So when it's not equal, the standard deviation.
Not necessarily. It could have been P equals 5 and P is not equal to 5.
Oh, and then,
Then that would be
parameter.
a two-tail and you were testing P.
Okay.
So whatever's in front is what you're testing. The not equal to just tells me it's a two-tail. Does that make sense?
Yeah. So the thing that's being tested is whatever's in the
Right.
equation.
Correct. All right, let's look at this one. Determine the null and the alternative. So they want us to do the H naught and they want us to do the H1. So the H naught is always going to be the equal. Okay? Now, historically, the time to order and deliver Jumbo's Pizza was 48 minutes. So the time is 48 minutes. The average time is 48 minutes. Jim, the owner, implements a new system for ordering and delivering pizza that he will believe will reduce the time. So is it going to be not equal to, a less than, or a greater than? So my H naught and my H1. The mean is what we're talking about. We're talking about the average time. Historically, the average time. So the average time is 48 minutes. But he wants to reduce the time, so he wants the average to be less than 48 minutes. Because they said the word reduce. So what kind of test is it? Left, and what are we comparing? The mean. That's all they want to know for this problem. Okay, look at this one. I want the H naught and the H1. Bless you. An average jar of peanut butter contains 32 ounces. Is labeled as containing 32 ounces, must contain at least 32 ounces. A consumer advocate feels that a certain peanut butter manufacturer is shorting customers by underfilling the jars. So what should our H naught be? Equal 32. What equals 32?
Mean.
The mean. Okay. What should our second one be? We know it's mean in 32.
Less than. Less than.
It's greater than it said at least.
It did say at least, but what are we trying to prove?
That they're underfilling.
Oh.
This is what we're trying to prove. We're trying to prove that they're shorting by underfilling the jars. So what is it gonna be? Less than. So the company is saying, if we got 32 ounces, we got 32 ounces or more. That is what they're stating. But the H naught is always gonna be equal. But what we're trying to prove when we go to court is that we're not short them, that it's not less than. Cool? All right, let's look at another one. 19.6% of children are overweight. A school nurse thinks that the percentage who are overweight is different in her school. So we need the H naught and we need the H1. We know this one's going to be equal. What is it going to be equal to? But give it to me as a decimal. 0.196. What's the number in the front going to be? The P. We're dealing with percentages. Proportions, percentages. So we know this is a P and this is 0.196. What's it going to be in between?
Not equal.
I did not say less than, I did not say greater than. I just said different. Not the same. Very good. Very good. So words like different, change, they mean not equal to. In 2014, the standard deviation of SAT scores for all students taking the exam was 112. A teacher believes that due to the changes in high school curricula, the standard deviations has decreased. So we need the H naught and the H1. What's the H naught?
112.
Standard deviation.
Are we dealing with a percentage? What are we dealing with? Standard deviation. What goes in between the last one? It has decreased. That's what we're trying to prove, that it has decreased. All right, let me see what I have left on my, two more real quick. Oops, not add a page, unload, cover up. 2.8% of high school students are currently using electronic cigarettes. A high school counselor is concerned for the use of e-cigarettes at her school, is concerned that the use at her school is higher. What is my H naught? P is equal to? Who? Who? 0.028. What goes in the last one? Greater, because it's higher. Okay, and one more. Migraine headaches, 15.2%. Stress is a major contributor. A massage therapist feels that her technique can reduce the frequency. Who? What letter? P, because we're dealing with percentages. Equal. Less than, because we are trying to prove, our H1 is what we're trying to prove. That we can work. Why are you fussing about this? This is bad. I don't like this. All right, so in 10.2 and 10.3, we're going to do some more with the hypothesis testing. Okay, so I have done everything up to 10.2 and 10.3. Homework is due Sunday night. Test is due tonight. Got to start it by at least 7:30. I am done. Are we done at 1:15? Yeah, we're done, aren't we? What time we get out of here? 2.
too, but if you're
Oh, no, I am not done. Why did I think we got out of here? Okay, are we good with this? Yay? Why did I have it on mine? One. All right, let me save as. I know, I don't know why I had that in my mind, in my head. 7.22.19. That is it for 10.1. Now we're gonna start 10.2. So all we did in 10.1 is set up the H zeros, or the H naughts and the H ones. Now we're gonna do 10.2. We got a page of writing, and then we'll do some problems. We only have 5 pages, and we're done for today. And then all I have left to do is 10.3 when we come back and we can review. All right, this is actually doing problems. This is 10.2, the hypothesis test for a population proportion. Hypothesis test for a population proportion. Testing the hypothesis for, that's easy to say. Testing the hypotheses for a population proportion P. We're going to use number 5, which is one proportion z-test in our calculator. This is known as the classical approach. I like the classical approach because I can see it, but I'm going to show you both approaches. So we're still going to have to do the H naught and the H1. We're just going to go further. Scroll up so I can let y'all copy. For your steps, you've got to identify the H naught, which we've already said has your equals. And then the H1 has your less than, greater than, or your not equal, and you're also going to identify everything else like your X, your N, and your alpha. You're going to determine the critical region, which is your Z alpha, aka the rejection region. You're going to use the alpha in the Z table, and you're going to draw the normal curve, shading the critical regions, or region. So you're going to identify the H naught and the H1, and everything else, X, N, and alpha. Determine the critical region, which is your Z, aka the rejection region. Use alpha in the Z table and draw the normal curve shading the critical region or regions. Use the calculator to find the test statistic, which is Z0, and run the one proportion z-test and plot on your graph. The decision rule is to compare the Z0 to the critical region to decide if you will blah or blah. Pull it up in just a second. So these are the steps for the classical approach, which is the one I like, just so I can see it. But I also will give you the p-value approach. I can't believe I almost let y'all have an hour. And mine's still at the beach. So once you graph it, then you'll decide, do you reject the H naught or do you fail to reject the H naught? I'm going to have have just a little bit more at the bottom, which is gonna be our p-value approach.
I went to, I went over there to get help with this, but I just couldn't get it.
Okay.
It was just so confusing.
Last semester? Oh. Hopefully we'll get it this time. Scoot down a little bit more until y'all tell me to scoot up. If the p-value is less than alpha, you reject the H naught. If p-value is found when you run the one proportion z-test. If it's less than alpha, you reject it. So after today, we'll only have one section, which means we will definitely start reviewing for the exam next time. And it's still more H naught and H1 stuff. All right, ready? Nexium is a drug that can be used to reduce acid produced by the body, acid reflux. The manufacturer of Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. In a clinical trial, 213 of 224 patients. Okay, what is the 213? The what letter?
The X,
The X. What is the 224?
N,
The N. So, X is going to be 213, N is going to be 224. Test the manufacturer's claim at the alpha of 0.01 level of significance. So, it claims that more than 94% of patients taking the Nexium are healed within 8 weeks. Blah, 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 blah. So, first thing we want to do is we want to figure out the HO, or H naught and the H1. What do you think the H naught and the H1 are going to be? We know this is an equal.
mean equals 0.94.
You're so close. 0.94 is not going to be my mean. What is it going to be? Oops. My P. Okay? So, what is the second one going to be? And how do we know? What are we trying to fight? What are we going to court to fight?
That
Are we doing less than, greater than, or not equal to for this? This is what we're trying to fight. Nexium says that it's equal to 0.94, but what are we trying to fight?
it's
How do you know it's greater?
More than.
It says right here, it claims that more than. That's why that one's going to be a more than. Are we good? Is it a left tail, right tail, or two tail?
right.
It is a right tail. And they told me that the alpha is 0.01. So I just identified a bunch of stuff. I did the H naught, I did the H1, I told that it was right tail because this was pointing right. They told me the level of significance, which is the alpha, and we know the X and the N, 213 people out of 224 people. We good so far? All right, so what we're going to do now is we're going to go to our table. Let me start drawing it. Standard deviation, our mean is 0, and that's gonna be 1. And we want our C's down here. Now, it's not going to be this last sheet, but it's gonna be the one right before it. It's called Table 5. Go with me? So not the single last page. Y'all were looking on the degrees of freedom before. It's the page like right beside it. It's got Table 5 at the top. We're going to be looking at the very bottom corner. Hypothesis testing critical values. Let me pull up so I can show you on mine. New. Copy. Paste. You can see it. So this is under Table 5. So we have an alpha of 0.01, a level of significance of 0.01, which is there. And we said that it is right-tailed, which is there, which means this is going to be my Z. So my Z-score is 2.33, and it is right-tailed. That's where that came from, 2.33. Are we good so far?
Hold on, this is from 0.5. Oh, and
At the
that's
bottom.
to 0.5. Okay.
At the very bottom right,
Yeah.
you see it?
Mhm, yeah.
Bottom right. So the alpha is 0.01, and it is right-tailed because it's greater than.
Yep.
So that gave me the 2.33. We shade to the right. Okay? All right. So now we need to get quote-unquote our data point. So to get our data point, we scroll down. We are going to go to our calculator. We are going to do stat, test, clear, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold on. Task manager. It is not liking me today. And task. Replace some of this stuff and see if that helps. We're going to do number 5. All right, so I'm going to do stat, test. I'm going to go down to number 5. Now, what do you think my P sub 0 is going to be? 0.94. What is my X going to be?
213.
What is my N going to be? Now, I have to decide which of these am I going to shade. Am I going to shade the not equal to? Am I going to shade the less than? Or am I going to shade the greater than?
Greater.
I'm going to shade the greater than. So I scroll over, and when I get on top of it, I hit enter. That makes it dark. Let me pull this down so you can see it. And then I'm going to hit calculate. And that tells me what my Z is, what my quote-unquote data point is. So my data point, my Z, is going to be 0.69, if I round it. 0.69. Are we good so far?
Yeah.
All right. Now, if it's in this area, we reject the H naught. If it's in this area, we do not reject the H naught. So if my data point fell in this area, I would reject the H naught. If my data area falls anywhere that's not shaded, I do not reject it. So am I going to reject or not reject? I am not going to reject it. If I calculated it and it was a 3, then I would have rejected it. So if it's in the shaded region, you reject it. If it's not in the shaded region, you do not reject it. So for this problem, we do not reject the H naught. And I'm going to come down and show you the prettier version. So we did the H naught and the H1. It was right-tailed. We went to our table and got the 2.33. This is, and they say fail to reject. I just say reject and do not reject. So there's my 0.69, so this is going to be a do not reject. We went to the number 5 and we filled in all the stuff. That's where we got the 0.69. And we do not reject it since it's in that non-shaded area. Now, the other way that you could have done this problem, let me get it from right here. The way that we just did it, they call the classical approach, is the way we just did it, which is the way I prefer. This is the classical approach. The other way is called the p-value approach. So after you do this, you get your p-value is 0.246. And if your p-value is, and I've got it down here, the p-value is 0.246. I'll show it to you down here. If your p-value is greater than your alpha, you do not reject it. If your p-value is less than alpha, you reject it. And in our problem, alpha was 0.01. So we have 0.2462, and our alpha was 0.01. And 2462 is greater than. That's why we do not reject it. So that's just the other alternative, if you want to memorize those two steps. If your p is greater than alpha, don't reject it. If your p is, I just got to physically see, is it in the shaded region or is it not in the shaded region? Now, I was talking to one of my other instructors that work with me, and she said that, you know, some of her students get in the groove like mine are, and she was teaching her heart out and was going over this, and all of a sudden a student looked up and said, "Why are you teaching about being a hoe and high?" Instead of H naught and H1, they saw hoes and highs. So, then she went out and she found, if the P is low, then the hoe must go. So, and then there was another one out there, "Hey girl, you must be P greater than 0.05 because I failed to reject you." So a lot of people like to remember though, if the P is low, then the hoe must go. So if the P is less than, if it's out of the region, then the hoe must go. You must reject the hoe. All right, let's try another one. Looks like we only have 2 more problems. According to the National Highway and Traffic Safety Administration, the proportion of fatal traffic accidents in the United States had a blood alcohol level of 0.36. Suppose a random sample of 105 fatalities in the state of Hawaii results in 51 that had positive blood alcohol levels. Does the sample evidence suggest that Hawaii has a higher proportion of traffic fatalities involving a positive blood alcohol concentration? So the first thing we want to do is identify everything that we can identify. So what is our ho and what is our high? What's our ho going to be?